In this lesson, we'll look at how to draw scatter plots and find and use prediction equations. How can a linear equation model the number of calories you burn exercising? The table shows the number of calories burned per hour by a 140-pound person running at various speeds. A linear function can be used to model these data. They did nothing with the rest of the problem. I was curious, so I went ahead and put the ordered pairs in the spreadsheet in Algebra to get a scatter plot, and Algebra will also do a linear regression for us. Now you can see that the best fit line is not a completely perfect fit, but it's pretty close. On the graphing calculators, it's R for the correlation coefficient. When I did it in GeoGebra, it gave me a B. So my correlation coefficient here is 0.99839, which is pretty darn close to 1. We like the correlation coefficients to be as close to 1 as possible, so that's a really nice one. And the equation is here in the algebra window, or I put it down below here. I can't point at it very well. On the graph itself. So now I could use this as my prediction equation if I wanted to predict how many calories would be burned at 10 miles per hour. I could plug that in. 20, I guess we're running, so nobody would be running 20 miles per hour. Probably not. Data with two variables, such as speed and calories, is called bivariate data. A set of bivariate data graphed as ordered pairs in a coordinate plane is called a scatter plot. A scatter plot can show whether there is a relationship between the data. The table below shows the approximate percent of students who sent applications to 2 colleges in various years since 1985. Make a scatter plot of the data. They labeled their horizontal axis years since 1985, which is a really common way of dealing with it because you don't want to put in all of those years. It takes more space, and that's how they have it labeled in the chart. They admitted they did the 1, 2, skip a few. They admitted they skipped a few from 0 to 12 with that little interrupter symbol there. And then they just went up by 2s. And then it's just a simple matter of plotting points. They labeled the vertical axis %, which came right from the table. And this data was about the percent of students applying to 2 colleges. Looks really nice and linear, other than this guy kind of looks like an outlier. He doesn't really fit the pattern. So except for the point 615, the data in example 1 appear to lie nearly on a straight line. When you find a line that closely approximates a set of data, you are finding a line of fit for the data. An equation of such line is often called a prediction equation because it can be used to predict one of the variables given the other. A data point that does not appear to belong with the rest of the set is called an outlier. When you are predicting an x for a value greater than any data in the set, the process is known as extrapolation. When you are predicting for an x value between the least and greatest in the data set, the process is known as interpolation. Draw a line of fit for the data. How well does it fit the data? Okay, that's about through the middle of the data. So in Mr. Wellner's class for science, you'll talk about when you draw a line of fit, you want to have about half the points above, half below, so it's all equally spaced. Of course, technology will give us the line of best fit, but this one's pretty good. Of course, a computer-drawn straight line is straighter than my free-handed one. Find a prediction equation, and then they ask what the slope and y-intercept indicate. Okay, so to find a prediction equation, we're going to pick our favorite 2 points, and the best 2 that look like they're on the line are 318 and 15. That goes with 13. So slope again, change in y. So 13 minus 18 over change in x. I get negative 5 over 12. Beautiful. I can use my point slope form now. So I have y minus the y part of my point. I'm just going to use the first one. Why not? Equals the slope that we found times x minus the x part of our point distribute that beautiful fraction. Negative times negative is a positive. The 3 and the 12 would cancel out, so it'd be 5/4. And then we're going to add 18 to both sides. If I left that all as fractions, I'd have negative 5/12 x plus 77/4, or you could write it as decimals. That'd be the same as negative 0.42x rounded to the nearest hundredth plus 19.25. Okay, then they ask us what the slope and y-intercept mean. The slope shows that the percent is falling about 0.42% each year. The y-intercept shows the percent in, this is years since 1985, should have been about 19%. To predict the percent in 2010, we're going to take the prediction equation that we found, and 2010 is 25 years after 1985, so we're going to replace x with 25 and put it in the calculator, and we get about 9%. How accurate is this prediction? Well, everything's approximate here, so the prediction may not be very accurate. If we use technology, we could know the level of accuracy better than doing it by hand, but it's good to practice by hand too. A scatter plot is a graph of ordered pairs of data. A prediction equation can be used to predict one of the variables given the other variable.